Good morning, students. Myself, Dr. Poonam Agrawal, Assistant Professor and Head, Department of Chemistry, Sri RLT College of Science, Akola, welcome you in this third video lecture, which is for ARYL halide. Now, in the last lecture, we have seen about the preparation and chemical properties of vinyl chloride as well as allyl chloride. Now, in this video lecture, we are going to see about the preparation and chemical properties of aryl halide, particularly with chlorobenzene and benzyl chloride. Now, aryl halides are those compounds which are obtained by replacing hydrogen atom of aromatic benzene ring by halogen atom. Chlorobenzene, it is a compound obtained by replacing one of the hydrogen atom of benzene by Cl atom. Cl attached to this aromatic benzene ring, it is known as chlorobenzene, which is obtained by replacing hydrogen atom of benzene by Cl atom. See, the molecular formula of this chlorobenzene is C6H5Cl, in which one of this hydrogen atom of benzene is replaced by Cl atom, and the Cl is attached to this carbon atom, which is double bonded. So it means that this carbon atom is sp2 hybridized carbon, and chlorobenzene, chlorine atom, in case of chlorobenzene, it is attached to this sp2 hybridized carbon atom, same case as that of the vinyl chloride. The Cl atom, in case of chlorobenzene, it is attached to sp2 hybridized carbon atom. Now see the synthesis of chlorobenzene. There are three methods in our syllabus for the preparation of this chlorobenzene. The first one is from benzene. Benzene on chlorination in presence of FeCl3 or even AlCl3 gives corresponding chlorobenzene. Benzene, whenever undergoes reaction with chlorine, one of the hydrogen atom of this benzene is replaced by Cl atom, HCl is removed, and this reaction takes place in presence of FeCl3 or AlCl3, and we get the formation of our required product, that is chlorobenzene. This is a very simple preparation method for chlorobenzene by using benzene. Benzene on chlorination in presence of chlorine carrying reagents like FeCl3 or AlCl3 gives corresponding chlorobenzene. Then second method for the synthesis of chlorobenzene is from phenol. Phenol, which is a C6H5OH group. Benzene ring attached with this OH group, it is known as phenol. One of the hydrogen atom of benzene is replaced by OH group. So this is a phenol compound, and by using this phenol we can prepare the chlorobenzene. Phenol on reaction with PCl5, phosphorus pentachloride, OH get replaced by means of one of the Cl atom, and we get the formation of chlorobenzene with the removal of POCl3 plus HCl. So this is the second preparation method for chlorobenzene, that is by using phenol. Phenol on reaction with PCl5, OH is replaced by Cl atom, and we get the formation of chlorobenzene. Any alcohol on reaction with PCl5 gives corresponding alkyl halide. So this is the same reaction. Phenol react with PCl5, OH is replaced by Cl atom, and we get the formation of chlorobenzene with the removal of POCl3 and HCl. So this is the second preparation method for chlorobenzene. First from benzene and second from phenol. Now the third preparation method for preparation of this chlorobenzene, it is from benzene diazonium chloride. See here the structure of this benzene diazonium chloride. This is a benzene group, N2. Azo group stand for nitrogen atom and di stand for 2. So 2 nitrogen atoms are there. So it is a diazonium group, and Cl is attached. This is a salt. Benzene diazonium chloride. Here structure, here presence of benzene ring which is attached to N2 group. N2 nitrogen, it is known as azo group, and 2 nitrogen atoms are there, so it is called as diazo compound. So this is a benzene diazonium chloride. Okay, benzene diazonium chloride. Now this benzene diazonium chloride, what happens? It reacts with this Cu2Cl2 compound, that is cuprous chloride, in presence of HCl. Then this N2 is removed and Cl get attached to benzene ring. Benzene diazonium chloride on reaction with this cuprous chloride this N2 is removed, Cl get attached to benzene ring, and we get the formation of chlorobenzene. This is the third preparation method for synthesis of chlorobenzene, preparation of chlorobenzene. The first one is from benzene. Benzene on chlorination in presence of FeCl3 or AlCl3 gives chlorobenzene. The second is from phenol. Phenol on reaction with PCl5, OH get replaced by means of Cl atom, and we get the formation of chlorobenzene with the removal of PoCl3 and HCl. And the third and important preparation method is from benzene diazonium chloride. Benzene on attachment with this N2 and Cl gives benzene diazonium chloride, which on reaction with cuprous chloride in presence of HCl, this N2 is removed, Cl get attached to the benzene ring, and we get the formation of chlorobenzene. So these are the three preparation methods for the synthesis of this chlorobenzene. Now related to the chemical properties of chlorobenzene, as I have already told you that Cl atom of this chlorobenzene is attached to sp2 hybridized carbon atom, and we have already studied that because of the presence of this sp2 nature, that is the percentage of S character is more in case of sp2, which is 33.33. This CCl bond is quite strong bond, and it is very difficult to break this bond, and hence the replacement of this nucleophile, Cl is a nucleophile, okay, so replacement of this Cl by another nucleophile, it is a quite difficult process. So what we can say that this chlorobenzene, it does not undergo readily the aromatic nucleophilic substitution reaction. It is quite difficult to remove this Cl atom of chlorobenzene. There are 2 or 3 reasons which we will discuss in the next video lecture also. But as we have seen in case of vinyl chloride and allyl chloride, as vinyl chloride, this Cl atom is attached to sp2 carbon atom. Again, percentage of S character, double bond character is there. So all these reasons are there why this CCl bond is a quite strong bond, and hence it cannot be removed easily. So this chlorobenzene, it does not undergo this aromatic nucleophilic substitution reaction easily, okay, but it undergoes electrophilic substitution reaction, and we know that the nature of this Cl atom, orientation of this Cl atom, it is a ortho and para directing group. In the last unit, we have seen about the ortho and para directing nature of this chlorine atom. So it directs the incoming second electrophilic reagent to this ortho or para position. The position next to this Cl atom, carbon atom attached to which this Cl atom is attached, it is called as ortho position. There are 2 ortho position, and exactly opposite position, it is known as para position. So this Cl, it is a ortho and para directing. So it directs the incoming second electrophilic reagent to this ortho and para position. Okay, second substituent group get attached to this ortho and para position as there is a presence of this Cl atom, which is a ortho and para directing. So this chlorobenzene, it shows the aromatic electrophilic substitution reaction at ortho and para position. Then again this Cl atom is attached. This compound, it is similar as that of the Rx group, and we know that alkyl halide, it shows the Wood reaction. Alkyl halide on reaction with sodium metal in presence of dry ether, it forms the higher alkane. The same reaction takes place with the aryl halide also. Aryl halide on reaction with sodium metal or zinc metal gives corresponding higher compound, and this reaction is called as fitting reaction. So chlorobenzene shows the fitting reaction, which we will discuss in the next slide. Now the reaction of this chlorobenzene, the first is simple reaction, that is reaction with aqueous KOH, potassium hydroxide reaction, which is a type of substitution nucleophilic reaction, nucleophilic substitution reaction, in which this Cl atom get replaced by means of OH group. We know that this is not an easy going process because the CCl bond is very strong bond, and it is very difficult to replace this Cl. So this is not simple as in case of alkyl halide, in which it reacts with aqueous KOH and immediately we get the formation of corresponding alcohol R bond OH. In case of this chlorobenzene, it reacts with aqueous KOH, but it is very difficult to replace this Cl. So we require high temperature, that is 623 Kelvin and 300 atmospheric pressure. The reaction takes place at about 623 Kelvin and 300 atmospheric pressure. This Cl atom is first of all form this potassium phenolate compound. This is a potassium salt of phenol, potassium phenolate compound, potassium phenoxide we can say. And this compound on acidic hydrolysis with dilute HCl gives phenol. In this way, this chlorobenzene on reaction with aqueous KOH gives corresponding phenol in two steps. In first step, chlorobenzene, it reacts with aqueous potassium hydroxide solution at about high temperature near about 623 Kelvin at about 300 atmospheric pressure. First of all, we get the formation of potassium phenoxide, and this potassium phenoxide on acidic hydrolysis with dilute HCl gives corresponding phenol compound. So this is a first reaction in which Cl is replaced by OH group. Then the second nucleophilic reaction in which Cl is replaced by NH2 group. That is the reaction of chlorobenzene with ammonia. It is not the simple reaction as that of the alkyl halide. Alkyl halide react with ammonia and simply we get the formation of RNH2 group. Rx plus NH3 forming RNH2 plus HX. Simple reaction. But in this case, this chlorobenzene react with ammonia in presence of cuprous oxide at about 473 Kelvin. The reaction takes place under pressure. Then and only then this Cl get replaced by means of NH2. And as NH2 is attached to benzene ring, we get the formation of aniline. Okay. So chlorobenzene on reaction with ammonia in presence of cuprous oxide at about 473 Kelvin under pressure gives aniline. CH5 NH2 group known as aniline. Then the third and last reaction of this chlorobenzene, it is reaction with sodium ethoxide. Now see here, whenever alkyl halide react with sodium alkoxide, then this Cl NaCl is removed and we get the formation of ethoxybenzene compound. NaCl, Williamson synthesis. If you remember the Williamson synthesis of alkyl halide which you have studied in 12th standard, Rx react with corresponding NaOR, then this NaX is removed and we get the formation of R bond O bond R dash, ether is formed. Same reaction is here. Instead of alkyl halide, aryl halide is here. Aryl halide react with sodium alkoxide. Here we have used this sodium ethoxide. Then this NaCl is removed and this OC2H5 ethoxy group get attached to this benzene ring. It forms the ethoxybenzene. It is a ether. Bond O bond group, functional group, ether is there. So it forms the ethoxybenzene compound. It forms the ethoxybenzene compound. So this is a third reaction of chlorobenzene, that is chlorobenzene on reaction with sodium ethoxide at about 473 Kelvin, we get the formation of ethoxybenzene. So three chemical properties are there in our syllabus. Action of aqueous KOH, which when reaction with chlorobenzene on reaction with aqueous KOH, potassium hydroxide at 623 Kelvin under 300 atmospheric pressure, first of all gives this potassium phenoxide. This phenoxide on reaction with dilute HCl, acidification, gives corresponding phenol. Reaction with ammonia, chlorobenzene on reaction with ammonia in presence of cuprous oxide at 473 Kelvin under pressure gives corresponding aniline. And thus the third one is reaction of chlorobenzene with sodium ethoxide at about 473 Kelvin gives corresponding ether compound, that is ethoxybenzene. Thus there are total three preparation methods for chlorobenzene and three chemical properties of chlorobenzene in our syllabus. Now remember the main thing, that is Cl atom in chlorobenzene, it is attached to sp2 hybridized, and as it is attached to sp2 hybridized carbon atom, this CCl bond is quite strong bond. It is very difficult to replace this Cl bond, and hence this Cl, it does not undergoes nucleophilic substitution reaction readily. So hope you understand the preparation and chemical properties of chlorobenzene. In the next lecture, we will see the synthesis and chemical properties of benzyl chloride as well as the reactivity of this chlorobenzene and benzyl chloride towards the aromatic nucleophilic substitution reaction. Okay, so hope you understand this topic. Thank you.